Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Are you tired of data migrations that drag on for months or even years? What if I told you there's a way to cut that timeline by up to a factor of 6 while guaranteeing accuracy? Datafold's Migration Agent is the only AI-powered solution that doesn't just translate your code, it validates every single data point to ensure perfect parity between your old and new systems. Whether you're moving from Oracle to Snowflake, migrating stored procedures to dbt, or handling complex multi-system migrations, they deliver production-ready code with a guaranteed timeline and fixed price. Stop burning budget on endless consulting hours. Visit dataengineeringpodcast.com/datafold to book a demo and see how they turn months-long migration nightmares into week-long success stories. Your host is Tobias Macy, and today I'm interviewing Akshay Agrawal about Marimo, a reusable and reproducible Python notebook environment. So Akshay, can you start by introducing yourself?
Definitely, and it's great to be here, Tobias. Thanks for having me on the podcast. My name is Akshay. I am the co-founder and CEO of Marimo, and at Marimo, the company, we're building Marimo, the open source Python notebook. It's built entirely from scratch, no dependencies on Jupyter or IPython. And at a high level, what we're trying to do is blend the best parts of interactive computing with sort of the rigor, reproducibility, maintainability of software. And there's a lot that we can, and I'm sure we'll go into to unpack what that means.
And do you remember how you first got started working in the data and or AI space?
Yeah, so I come from the AI angle, I guess, and that was sort of my introduction to data. So I have a background in both machine learning and computer systems, and so my first job out of, I guess, my master's, out of my undergrad master's, was at Google. So I was on the Google Brain team working on TensorFlow, and specifically TensorFlow 2. So I joined before TensorFlow 2 was released. I was on a small team of, I think, 6 people who were working on TensorFlow 2 in particular. And so I was building dev tools for people who do machine learning. And then after that, I did a PhD at Stanford in machine learning research. And then so I was, still building dev tools, but also applying it to sort of a variety of real world problems and working with a bunch of unstructured data.
And so that brings us now to the Marimo project. I'm wondering if you can just give a bit of an overview about some of what it is, the goals that you have for the project, and some of the story behind how you decided that this was where you wanted to spend your time and effort.
Definitely happy to talk about that. So what is it? It is a new kind of Python notebook. And there's actually several ways that makes it a new kind of notebook. Let me highlight a few of the ways and then work backwards to the story of why we're doing this. So one way that it's different is that it is what's called a reactive notebook. So what that means is that we try to satisfy a guarantee that the code on the page matches the outputs you see, eliminating a problem known as hidden state that's commonly associated with traditional notebooks like Jupyter, where you can run a cell, but then you forget to run some other cells, and now your notebook is in some inconsistent, invalid state. So that's one. It's called reactive execution. Another way it's different is that we fully embrace Python, whereas Jupyter is multi-language, language agnostic, so they store their notebooks as JSON. We go 110% all in on Python, so the notebook is stored as a Python file. You can reuse it as a module, import functions and classes. You can even run it as a script. You can version it with Git. So we're really designed for Python first work. A third way that it's different is that every Marimo notebook comes with a bunch of UI elements, like UI widgets built in. And these UI widgets, actually, you create them programmatically. You import Marimo as Mo into your library, and then you have sliders, interactive tables, interactive charts, and a whole lot more. And you can use these not only to explore your data really rapidly, but you can use them to seamlessly convert any Marimo notebook into like a data app, should you want to. So sort of like Streamlit, but more performant. And also you don't have the notebook to like data app migration cost. Those are a few ways that Marimo is different. We also have like built-in package management, and like we can create isolated VEMVs for you and do like package reproducibility. But maybe now I can talk a little bit about the backstory that'll sort of explain why all these features exist and sort of hint towards what other things might be in Marimo. So I mentioned my background at Stanford and at Google before that. And so especially at Stanford, so I was doing machine learning research, and I specialized in vector embeddings and dimensionality reduction. And so what that means is you have some high dimensional data, which looks like essentially a list of lists of numbers, right? A vector is a list of numbers. So you have many lists of numbers, and those lists have a lot of entries. Those vectors have a lot of entries. And you want to compress those vectors into a smaller representation, so dimensionality reduction. So I worked on algorithms for that. And in particular, I would often compress into 2 dimensions so that I could plot my original high dimensional data in like a low dimensional like scatter plot. So you can visually look for clusters and things like that. So because of that, I used Jupyter notebooks like almost on a daily basis. And they were super useful because I could see my data while I worked on it. Like the data was held in RAM, and like so you could iterate really rapidly. So super useful for that reason. But then there were also some shortcomings that like made my work more difficult than I felt like it should be. So one was like the lack of true interactivity, and I'm not talking about like the shift enter run a cell interactivity, but like almost like the interactivity you see like in Minority Report or like these sci-fi movies where like you're like touching the data. Like so for example, I wanted to get like a scatter plot, select data, and then trace it back to like original points in Python. That kind of interactivity was really hard to do in Jupyter. You can't do it in Marimo today. Another thing that was hard was the hidden state. So in particular, like you could delete a cell in Jupyter, and that cell might have declared like some really important variable. It could have been a long cell, and hidden somewhere was an important variable declaration that you forgot about. You deleted it, and then you continued hacking on the rest of your notebook, and it was working. But then you come back the next day, you restart your notebook, and nothing works. And that's because in a traditional Jupyter notebook, when you delete a cell, the variables are actually still in memory. And that leads to accumulate. That's one way that these notebooks accumulate hidden state. Marimo solves for that problem as well in ways that we can talk about. A third problem was the file format. JSON is good for broad compatibility across a bunch of different languages. It is not good if you're trying to version with Git or reuse code. And so I had a bunch of untitled IPyMBs kind of scattered everywhere in my directory. And then the last problem was this idea of like package reproducibility. And like this is not necessarily specific to Jupyter. This is true for like Python scripts too. Like sometimes you forget to keep track of what packages you used while working on a Jupyter notebook or a script. Sometimes your colleagues forget to do that. And then they send you the file and you're like, how do I run this thing? I don't know what versions of packages you used. Marimo has a built-in solution for that as well. So I experienced these problems firsthand. I wasn't the first to notice them. But having a background as a software engineer, I did want to do something about them. So then once I finished my PhD, that was early 2022, I was lucky enough to get like a subcontract with the Stanford National Lab to build out the open source for a couple of years. So I got real-time feedback from folks who really know their stuff and were really passionate about a new kind of Python notebook for interactivity, sharing as apps, reproducibility. And so that led to the creation of Marimo, and my co-founder and I did get funding from the founder of Kaggle last year. We are building a company, and now there is we have a handful of very strong engineers working on the open source and pushing it forward.
So there's a lot to dig into there. So I, as a Python person, have definitely encountered Jupyter notebooks and have dealt with many of the challenges that you've addressed, and also the fact that if you want to edit or interact with one of those notebooks, really the only way that you can do it is if you are using their web interface for editing. It's very difficult to actually plug it into your editor of choice unless there is an existing plugin for that editor, and even then it's not a one-for-one comparison. And so I can definitely appreciate the pure Python aspect. And I think one of the things that is probably worth exploring early in this conversation is your dedication to Python as the primary interface for these notebooks, and deciding that you are explicitly not going to try to solve for the multi-language capabilities that Jupyter offers through their various language kernels. And I'm wondering if you can talk to some of the ways that you thought about that utility and what the actual value is versus just the perceived value of being able to use multiple languages within a single notebook construct.
Yeah, definitely. So let me see. There's a couple of reasons why we really lean into Python and how we get benefits from it. So one set of reasons has to do with the file format, and I'll get into that. There's actually a lot of benefits, it turns out, if you lean into one language. And another set of reasons has to do with like the actual like notebook experience. So I mentioned like one of the main ways that Marimo differs from Jupyter notebooks is that it is reactive. It has reactive execution. So what that means is if you run a cell, Marimo first statically parses it. It parses the Python code and then gets the variable declarations and references. Then when you run that cell, it knows all other cells that need to run that have any references to the variables that this cell declared. So it like kind of like a spreadsheet where like you run a cell, Marimo can automatically run dependent cells. If your notebook is expensive, you can make this execution lazy, so like it'll just mark them as stale. But the point is, so that's one area where like specializing to Python is actually really important, at least in the runtime, because like we're using the Python AST. There's a lot of logic there that's specific to one language. And then another area, as I mentioned, these interactive elements, right? Like sliders and things like that. We wanted to make an experience that felt really nice from a developer perspective. So instead of having like point and click to create UI elements, which maybe would afford some language agnosticism, like Marimo is a Python library. Just import Marimo into your Marimo notebook. It's a little bit meta, but now you have access to a bunch of UI elements, but also like control flow elements, like cool things that let you like watch files and stuff on disk and like auto run if something changes. So like we've got a bunch of utilities that we can sort of bring to bear by assuming that you're just working in a Python notebook. Also, our front end is like very specifically designed for Python. Like instead of doing like bang pip install to install a package, you just like type import and then like a little like toast appears that says like, hey, like you want to install this package? Do you want to use UV? You want to use pip? You want to use Conda or Pixie? Like, what do you want to use? So there's a lot of specialization in the front end too, assuming that it's just Python. A lot of the interesting stuff about like okay, maybe you can imagine doing some of that still in a language agnostic way with just a specific front end. The file format, though, by being pure Python, we actually get a lot of really cool benefits. So the most obvious one is short stored as code, so you can version it with Git. But there's like more, like you can test your notebooks with PyTest. Like you can either name your cells or like have test functions and then run PyTest mynotebook.py and it'll just run the test functions. You can reuse functions and classes from a Marimo notebook in other Python modules. You just type from my notebook import my function, as long as that function satisfies some constraints, and then boom, you have it. And unlike in a Jupyter notebook, because it's like this JSON file, like what they have is they have this include directive, but that runs the whole notebook and then just puts everything in your globals, which is never what you want. Like you just want to get the named symbols out without running any code besides whatever is defining the variables. You can run as Python scripts, even with CLI args. Like, so here's another example. Like, you can just like import arg parse into your notebook, or like use some utility functions we have, like mo.cli args to make that easier. And now your notebook is a script. Also, by embracing Python, like both in our CLI and the file format, like we can take advantage of new Python standards. So, for example, I mentioned reproducibility and packaging. Python has a standard where, like, in a script, and a Marimo notebook is a script, you can in a comment at the top document what dependencies that script has. So you can say this uses PyTorch version, I don't know, 2 point whatever. This uses NumPy version blah, blah, etc. It looks like a mini embedded a PyProject TOML. So Marimo supports that. And we can actually, if you want, auto-generate those dependencies for you in the notebook file. And then our CLI, we're like, okay, we know this is a Python file. We know these are Python packages. We can create a temporary virtual environment for you that automatically installs those packages. And then finally, yes, of course, you can edit as a plain text file in NeoVim, in Cursor, in VS Code, wherever you are. And Marimo can watch for those changes and update. Long answer, but yeah, happy digging into any one of those. But those are some of the really key benefits you get by really specializing, I think, on one language.
And there's also the built-in fact that Python is one of the dominant languages, particularly when you're working in data or AI and machine learning. Another interesting aspect of the problem space that you're addressing is just the overall concept of programmatic notebooks, which have been around for decades at this point. I think MATLAB may have been one of the first ones, if not the first, and that was where a lot of people, particularly in academia, particularly in some sort of numerical field, first encounter programmatic notebooks. I know that that was actually some of the inspiration behind the Jupyter project, was wanting to be able to access that style of computation without having to pay the premium for it. And as Jupyter has grown in reach and adoption, there have been numerous other notebook style projects that have started as a result. I know that the Elixir community has a notebook format. I believe Ruby may have a notebook format. There's the Databricks notebooks, and then there are commercial notebook style companies out there, Hex being the one that comes to mind most readily. And given the reach and the style of computation that notebooks promote, I'm wondering, as somebody who is building in this space, how you see the overall evolution of notebooks as a core computing primitive changing as they have become more broadly adopted outside of academia.
Oh, I love that question. Yeah, I like to think of the first notebook as being like VisiCalc or like Excel spreadsheets, right? Like you have cells, you type in data, and you have formulas, and you see outputs. Yeah, so like I think like the history is really interesting. So okay, I've done like reading about like Mathematica notebooks and MATLAB style stuff. I'm aware of like R Markdown, R Shiny, but I have to like mention that my experience has been, the first notebook I ever used was the Jupyter notebook. The first Python REPL I used was, I guess, the Python REPL and then IPython. So that's where I have the most hands-on experience. But in terms of what I've seen from the evolution, so like Jupyter notebooks, I think came out as a natural evolution of the IPython REPL, but like language agnostic. So like you had a REPL in the console, yeah, that's kind of interesting. It is interesting. You have a REPL in the browser. That's very interesting because like now you can have like all your outputs, you can have your code all kind of in one place. But then I feel like something interesting happened where like, if you're using an IPython REPL, you're using it to kind of explore data maybe a little bit, and you're using it to explore APIs. You're not like training like a model end to end, and you're not doing all your data engineering in IPython REPL. Like you're going to write a program, right? But then something interesting happened because like you had like a Jupyter notebook, and it was a collection of cells that could be ordered from top to bottom in a linear sequence. Kind of look like a program, right? And then like, but like with superpowers, because like you could like live debug it, because like you see your outputs while you're working on it. So then people started using them to train machine learning models, to run Databricks workflows, right? Like to run data pipelines. They started using it for all these things where like reproducibility is paramount. And I think that was like a really interesting, I don't know, phenomenon that happened where like, and I think like led to notebooks being so widely used because they're data engineering, machine learning engineering, like education, all these different disparate use cases are like, oh, this is they recognize interactivity as being something really valuable. And then in terms of the evolution, yeah, so I guess because Jupyter is not only language agnostic but also designed as this like system of like interoperable modules or like specs, right? You have like the kernel spec, and then you can have a custom front end for it. Like I think like Databricks notebooks, Colab, even Hex, I believe, is using the IPy kernel. Like so, they're all like in some sense like skins and customizations on top of the Jupyter like protocol, and that is like a testament, I think, to the like engineering that like and system design that the Jupyter team has done, that it's been so extensible. At the same time, like I think like because of that, like most of these commercial notebooks haven't really innovated much in like the core paradigm of like what a notebook is, and so like Databricks notebooks have like all the same problems with notebooks that I have sort of mentioned at sort of the beginning of this conversation. There have been innovations in other languages. So Livebook is a good example from Elixir. My main inspiration actually came from a notebook for the Julia programming language, also open source. So we're Apache 2.0, and I think Pluto, the Julia notebook, is either Apache or maybe MIT. But anyway, so they're a reactive notebook that is stored as pure Julia, that has interactive elements that you can run as a script. It doesn't have like the data app part and some other features that we have, but Pluto was a huge inspiration to me. So like I saw Pluto, I'm like, these are like features from the future. Like every notebook needs to work like this. Why hasn't anyone built this for Python? So sort of like that was a huge inspiration for me setting out to build Marimo. You did mention Hex, which has like, if you like kind of squint, if I took off my glasses and like looked at both and like read the feature specs, like they're kind of similar. Like Hex has reactivity, Hex has some UI elements. The main differences I think maybe come from like who they're designed for, and then it like goes into like feature differences. So like my understanding is that Hex is increasingly focusing on like business intelligence use cases. And so like for that reason, like, they have no innovation on like the file format. In fact, like Hex is proprietary, right? Like you can export as IPyMB, but you can't run that like locally because it uses all these custom Hex things. But so they have no innovation on the file format, and so they don't get innovation on like reusability, maintainability, reproducibility. Their UI elements are like point and click to create rather than being composable like ours. So that like really limits the kinds of things that you can build. Their reactivity system, there probably was some intentional design choices behind it, but like it doesn't go far enough to actually enforce that your notebook is well structured. So in Marimo, like, so if you have a reactive notebook, what that means is that your notebook is actually a directed acyclic graph, or at least it should be. And so if you violate that, if you like define the same variable in multiple cells, or if you introduce a cycle, Marimo tells you, hey, like you did something not cool. Here's how you fix it. That doesn't happen in Hex. Hex also lets you doesn't do the variable cleanup, I believe. Last I checked, that we do. So in Marimo, you delete a cell, we delete its variables from memory, make sure everything is consistent. That doesn't happen in Hex. So like Hex is, in my opinion, like a movement in the right direction. They just didn't take the ideas far enough, and that might just be because they're serving different users than us. Hopefully that answers your question.
Yeah, absolutely. And so digging more into that visual aspect of Marimo, the ability to take the analysis or computation that you have built through the notebook and then publish it as an application, digging a bit more into the juxtaposition of Hex and Streamlit. I'm wondering if you can talk through some of the ways that you think about the goals that you have for Marimo and its role as being an app creation utility.
Yeah, definitely. So whereas I do view Marimo as a notebook first, so as a alternative to Jupyter notebooks with more guarantees, more interactivity, more batteries included, I also view it as a complete substitute for Streamlit. So like actually many of our users, it's funny because we have users coming from like many different directions. Many of our users, not all, but like many of them came because they were looking for an alternative to Streamlit and have since migrated away from Streamlit to Marimo. And the reason is I think like many Streamlit users, not all of them, but many of them often start in a Jupyter notebook and then port it to a Streamlit app. You look in the like repos that have a Streamlit app, there's an IPyNB file and then there's a py file, and it's just like a translation. So one, Marimo collapses the space, but two, also because Marimo is a DAG, like say you scrub a slider, you say x equals mo.ui.slider, and then some other cell depends on the value of x, like x dot value. That's sort of the convention we have. In Marimo, you scrub the slider, only the cells that read the variable x are going to run. In Streamlit, you scrub your slider, the whole script runs from top to bottom, and that is really hard to reason about. Not to mention, like, you're like, okay, well, now my thing, first of all, maybe you don't have, your correctness is, like, things that just are not working, like, you know, because that's not a natural way to think, in my opinion. But also, then you have performance issues, then you have to think about ST cache, then you have to think about, like, Streamlit, like, session cache or so things get really complicated fast, whereas in Marimo, it's just, like, just kind of makes sense. So I mentioned Anthony Goldblum being the founder of Kaggle, being one of our main investors. And the way that happened is that at his new startup, Sumble, he first started using Marimo, and he started using it as, I believe he started using it as a Streamlit replacement, or at least he was doing a lot of Streamlit-like stuff. And then he eventually migrated totally off Streamlit onto Marimo. And then once we added GitHub Copilot to Marimo, then he migrated totally off Jupyter onto Marimo. So like he did like expand, like replace both tools for his use case.
And so with Marimo in the context of a data team, there are many different activities that are taking place as you go from data engineers managing data ingest, cleanup, preparation, contextualizing those assets, and then move into business analytics, where somebody might be working primarily in some form of business intelligence suite, but maybe they need to do some sort of interactive analysis or evaluation or exploration of the data. And then you move into the ML and AI engineering space, where people are either building and training their own models or doing model evaluation or model fine tuning for some of these foundation models. How do you see Marimo as a utility being applied both within those different contextual boundaries and then also being applied across those use cases?
Yeah, so that's a great question. I mean, Marimo being a notebook first and foremost, like I mentioned that like And you mentioned just now how notebooks have so many different use cases. We're seeing the same thing with people adopting Marimo. Like they'll use it for data engineering, data science, machine learning research, machine learning engineering, cybersecurity, which was cool to see, and just like run books. So all kinds of different use cases because it's such a flexible tool. In terms of cross-functional, I think like the cross-functional sort of like uses come in like two flavors. So one is obviously we're talking about apps. That one, people are actually like making apps that their CEOs use. Sometimes CEOs are making Marimo apps themselves, and not just me, but Anthony Goldblum and some other big companies too. And then another one that's more subtle in terms of cross-functional use, but I think important to call out is also like, there's like this historical, especially in like the machine learning like profession, this like historical concept of research to production handoff, right? And what that usually means is the researchers have these Jupyter notebooks that are kind of messy, and then they're like, okay, like figure out how to make this useful. With Marimo, because the notebooks are Python files, because the notebook is a DAG, actually, it turns out for your Marimo code to work, it kind of actually has to be written somewhat well. So one of our users called this like gentle parenting, like we just nudge you to write better code because otherwise it just doesn't work. But then also because like the functions can be made reusable, it like makes the handoff easier because they can say, well, you can write tests, you can force your researchers to write tests, and you can also say like from my notebook import my function, and so then all of a sudden maybe that's easier to like stand up an endpoint or something like that. And then in terms of like data pipelining, in the simplest case you can just like cron a notebook like as a script, or like run it and like export to HTML or even IPyMB if you want outputs. We are exploring, but don't yet have much to share yet, of like a more sort of intentionally designed pipelining experience with notebooks as like sort of a unit. That'll be in the future in terms of, we're in the ideating phase for that.
That was going to be one of my next topics to discuss, is that aspect of once you have a notebook, it does the computational job that you have designed it for, and then you want to operationalize it, where because it's just a Python script, you could conceivably stick it into some orchestrator, whether it's Airflow, Dagster, Prefect, etc., and just have that be some portion of the pipeline logic. I know that one of the projects out of Netflix a while back was Papermill, which was intended to apply that same type of utility to Jupyter notebooks and make them a little bit more constrained so that they are a little bit more reusable, where you add in some parameter inputs for the notebook, it executes top to bottom and generates an output. And I'm wondering how you're thinking about the role of Marimo in that orchestrated computation context.
Yeah, I really like that question. So in the first example, like you're right, like yeah, you could just Marimo's a Python script, you throw it into whatever orchestrator you like, and you can use it there, and people do. In terms of Papermill, it is interesting because, like I mentioned, like you can like honestly just like use arg parse or click or whatever in your Marimo notebook, and the arguments get parsed out, and so like you can build your own little thing based. You just have a Python script, so do whatever you usually do for like enumerating, I don't know, runs of the Python scripts with different arguments. And like I mentioned, you can export to HTML. We want to design something a little bit like it's very tempting to design something a little bit more intentional for pipelines for a few reasons. Like one, like you look at a notebook, it's a DAG. So like so many of our users are like, oh, you guys have a DAG structure. Like, can you exploit that? Like if you have multiple cells running some, async data loader functions, like can you run them like concurrently? Can you run some expensive cells in parallel? And yes, we could in principle. We aren't doing that right now. And so that would be a way to kind of like exploit the structure of our notebook for, I suppose, performance reasons. And then also like while you can, yeah, stick notebooks in like an orchestrator as like a step, like it would feel better to me if there was like a more intentional API for like putting these notebooks together as opposed to just composing them as just Python. Right now, I just to be clear, I'm in total speculation mode. So like we've had like a couple of brainstorm sessions with our team, but like haven't really had time to make progress on that yet. But I think there's something cool that we could explore.
And the other interesting challenge that I see around notebooks is that they are typically very much a single player mode utility where somebody is iterating locally on their laptop, or maybe they are hooking into some distributed compute framework such as Ray or Dask or Spark or whatever it might be. And I'm wondering how you're seeing teams who are adopting Marimo approach the challenge of making them a little bit more visible, more multiplayer, and in particular, easing the friction of getting those people who want to do some sort of exploratory analysis access to the underlying data, such as their data lake or data warehouse, etc.
Yeah, that's a really good question. So one way that it becomes more multiplayer, kind of interestingly, is actually goes back to just the file format. It's interesting because like with the Jupyter notebook, like you can use, I think like the Jupytext plugin or something that like strips out outputs and then like converts it to like a Python representation. So you can get a Python file format with Jupyter. You just need to set up some CI thing and like a pre-commit hook. But somehow like a lot of people, I'll be talking to Marimo about introducing Marimo to someone, and I'll like rattle off a list of features like reactive execution, interactive elements, data apps, run as a script, version with Git. And then when I say Git, like their eyebrows like pop. And so like somehow that's been like the entry point for a lot of teams. And so like data team leads have sometimes like adopted Marimo sort of unilaterally, saying we're doing this because now we can code review your notebooks. And that's actually like one way that's some kind of, in some sense, software engineering multiplayer type of experience happens. Obviously, another way that these things become multiplayer beyond the Git, beyond the reusing of functions, is of course apps. So there's a startup that's like running their like sales team on like Marimo notebooks, Marimo apps. Like they made a bunch of Marimo apps for go to market, and then like the sales engineers or the sales representatives can just like run them and like have access to their data. In terms of like getting access to your data lake, so there's a few things. So like Marimo, I should have mentioned this earlier, on the data engineering podcast. Marimo's a Python notebook. It has native support for SQL, so like you can create SQL cells, and by default the SQL cells use DuckDB, so like you can just query data sort of in memory. But we also have support for like connecting to a variety of different databases and data lakes. So like you can connect to like an iceberg catalog through a little side panel. You like set up your credentials and your environment variables. Then you can just kind of you have access to your data, and then it also shows up. We have a data sources panel that like shows you like what's in your catalog, and like lets you explore schemas and stuff. So that's one way we're making it easier to work with your data. Of course, I think like the real to do this at scale at a large enterprise, large enterprises are not going to be happy with everyone just kind of like rolling their own solution with their own environment variables on their laptop. So that's part of where our commercial solution will come into, which, to be clear, we haven't launched yet. We're still building out, so there's not too much that we can say about it right now. But I think you could imagine of like there's a lot of things that enterprises want for when working with notebooks, and it's all the surrounding stuff that the notebook touches, like what you're alluding to.
And one of the other means of multiplayer mode that I've seen, at least in the Jupyter space, is through the deployment of something like a Jupyter Hub or a Binder installation, so that somebody can go to a web UI, say, give me a new notebook, and then they can start working on it. And I'm wondering how you're seeing, either in the open source or people building tooling around it, or in your not yet formed commercial offering, how you're thinking about that 0 to 1 step of, I just want to be able to click a button and start hacking and not have to worry about finding my credentials, setting up all of the connections. I just want to be able to start running and have something already set up, maybe through some sort of integration with a business intelligence framework or some other sort. So speaking personally, I'm thinking in terms of how do I hack this into my superset deployment?
Yeah, great question. So obviously, stay tuned for a commercial launch. But before then, so there has been work from the community, so that there's a GitHub repo, Jupyter-Marimo-proxy, I think, that lets you run Marimo notebooks, or makes it easy to run Marimo notebooks through Jupyter Hub. And so some people are successfully doing that. And I would recommend anyone who's using Jupyter Hub and wants to try Marimo to check that out. I haven't heard about anyone using it within Superset, so I would need to learn more about what that infra is like. But the hooks, I think, are there. If someone can do it for Jupyter Hub and Jupyter, I think it should be possible to add launchers elsewhere. We've been talking to other companies too that are interested in like offering Marimo to their users. They're also exploring like how do we do this natively. But yeah, if you're using Jupyter Hub, it's definitely doable. And part of the reason I know this is because, well, people reach out to us, tell us they're going to try it, and also there's a course at Berkeley, like an undergrad EECS course, that is going to use Marimo notebooks, but they do everything through Jupyter Hub. So then they've set it up so that their students go to Jupyter Hub and start their Marimo notebook.
And then digging now into a little bit more of the technical elements of Marimo, you've mentioned it's reactive, it's Python first, it has all of these UI capabilities. And I'm wondering if you can just talk to some of the architecture and system design and some of the interesting engineering challenges that you've had to tackle in the process of getting to where you are today.
Definitely. So let's see. So I mentioned we built Marimo entirely from scratch, right? So we're not using IPy kernel, we're not using the kernel protocol. This is mostly so we could just like, I don't know, move really fast and like just elegantly hack together whatever, connections we need between our front end, our back end, and anything else that we're doing. Yeah, surprisingly, I guess, maybe not surprisingly, it's not that hard to build your own kernel thing that runs Python code and communicates it to the front end. Like, use WebSockets. I don't know. This technology has gotten pretty mature. Some things that were hard or just required sort of subtle thought were like implementing like the parsing logic on the back end. Thankfully, Python has an AST module, but like there's like a lot of edge cases you got to cover because everything is done in Marimo through static analysis. Like, I think maybe at a higher level, the harder thing to do was like just like the engineering design of like, well, how do you do a reactive notebook in Python? Like, are you going to do runtime tracing or are you going to do static analysis? And we decided against runtime tracing because like impossible to cover like all edge cases of like tracking when variables change. Also like figuring out how to make using UI elements really seamless. Like that's something that like as a user you don't notice, which is good because good design is invisible. But like figuring out how to do that was like kind of subtle. And like because say you do x equals mo.ui.slider, and then the next cell you do x.value. Well, you actually don't know until runtime that like there's a slider that's bound to a variable x, right? Like, but I just said we do everything through static analysis. So like, wait, what's going on? And so there was some like clever things that we kind of needed to do. Like we do know the variables, but at runtime, then when we find a UI element, like we have a registry of all the UI elements, and you do a reverse lookup in the Python globals to like match UI elements to the globals to then form a binding. So we have like some kind of late binding, I guess you could call it in that sense. Another thing that was difficult and that Dylan, an engineer on our team, is working on is like caching. So like it's a reactive notebook. Things can automatically run. I mentioned you can turn off automatic execution too, but like ideally you're in this flow where you're automatically running things and seeing live updates. So okay, you probably want some kind of caching in there, right? So like if you change values, you cache things you've already computed. So we have our own sort of plus version of like functools.cache as well as a persistent cache. The reason it's plus is like, so you imagine you're using functools.cache in a notebook. Well, anytime you run the cell that has at functools.cache, it clears the cache, which is not what you want, especially if the notebook's reactive, right? So our cache can persist across up cell runs, and it's also not, it doesn't just index on like argument values, but rather it like has the context of the source code of the cell, the ancestors of the cell, and Dylan is a big Nix fan, and so he has studied Nix closely and has built some of those concepts into our caching system. There could be a whole podcast on just how he's doing that. I think that's one of the rather sophisticated challenges that we've had to tackle.
And as you have been building Marimo, putting it in front of people, seeing how they're using it and adopting it, I'm wondering what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
So let me see. Early on, I guess I think one thing that's cool about notebooks is that like the use cases are so broad, and like now these things don't surprise me as much because I've seen them happen again and again. But like when I first saw someone using Marimo notebooks for doing, it's called like threat hunting or something like that, a cybersecurity concept. Like it's like, wow, that's really cool. Or when I first saw a DevOps engineer use Marimo to like monitor and also like take actions on like a EKS cluster. I'm like, whoa, that was cool. These days, like the most surprising things actually come from one of our engineers who is just a creative genius. His name is Vincent Warmerdam. He's actually been making a lot of really cool interactive elements and like custom widgets. We have an extension. We hook into an open specification for like widgets called AnyWidget, developed by Trevor Mans, who now also works at Marimo. AnyWidget's separate from Marimo, but it lets you build your own interactive widgets using JavaScript. So Vincent has built some really cool things. Like instead of a 1D slider, he made a 2D slider. Instead of controlling with your notebook with a mouse, he actually found a way to hook up a video game controller, a gamepad to your Marimo notebook. So like you can like, and then he built like this data labeler, and like, you know, you just hit like A B, like really quickly go through and cycle through like data that you're labeling without getting RSI because you're not using your mouse. So I think that the gamepad actually was actually quite inspirational to a lot of people when they saw that. Really opened up. Oh wow, you can kind of do anything with this thing.
And to that point of extensibility, you mentioned the integration with any widget. Obviously, Marimo is pure Python at the end of the day, so you have the entire Python ecosystem available to plug into. I'm wondering, too, in particular, for folks coming from Jupyter, there are a number of interactive elements, UI capabilities built specifically for the Jupyter notebook environment. I'm just curious how you're thinking about the extensibility and ecosystem building around Marimo to enable some of that more plug and play functionality.
Yeah, that's a great question. So we've now added like support for like definitely all of the popular sort of interactive elements that like work in Jupyter. Like so, like we hook into like the IPython like display protocol. So like if you use the underscore repr underscore HTML whatever SVG, like it'll render fine in Marimo like, correctly. And then all the major plotting libraries like Matplotlib, Plotly, Altair, all of them, they all work in Marimo. Data frames. Actually, in Marimo, your data frames are like actually far more interactive than they are in Jupyter. Like you actually get an interactive table that you can sort, filter, search, etc., instead of static HTML. So right, okay, so we implement the display protocol, so the IPython standard, and then honestly, any widget is helping because modern widgets now are in the Jupyter ecosystem. People actually develop them with any widget, and we fully support the any widget spec. So if you make an any widget for Jupyter, it works in Marimo. In terms of like, then there's then there's like a bunch of extensions like that people have made for Jupyter. We try to provide a really batteries included experience. So like we have first class Vim key bindings for any data engineer out there who likes that. Like that's already built in. We have a VS Code extension, and we're working to make it more native, like similar to the Jupyter one. We have like code formatting built into the editor, so like a lot of the things that an engineer type would want, we have. We don't have a public like extension API beyond any widget right now, so that's just for interactive elements. And the reason is that like, well, we move really fast, and right now we don't have enough confidence to like open up the internals in a stable way. So instead, we say make a feature request, and if it's with the roadmap, we like our informal SLA is really fast. So we ship a lot, like a lot. Our CTO ships a lot, so we try to just engage with the community on whatever gaps there are. One day, I'm sure we will have a more proper extension API, but not today.
And in your experience of building Marimo, building a company around it, engaging with the ecosystem, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think it's like somewhat of like a social thing of like we have a pretty large community and very vocal, so we like really encourage feedback. And a lot of our users, we do are coming from Jupyter, right? And so Marimo is very different from Jupyter in some ways, even though when you just like look at it, it looks, it's a notebook. You have cells, you have outputs, but like reactive execution in particular makes the runtime like very different and like the way you write your code. So sometimes, people will come in with requests like, I want a compatibility mode that not only turns reactive execution mode off, like we have a lazy execution, but that still gives you guarantees on state, and that still doesn't allow you to break the DAG. You still have to have a DAG, it's just lazy. Some people say, especially in the beginning, we had a number of people saying like, just turn off all, just give me just total IPyKernel imperative API. I love all your UI elements. I love your UX. I love your visual design. I don't want reactive execution. Turn it off. Like, let me turn it off. So we had a number of things like requests like that, and like we ended up just taking like a really principled stance of being like, thank you, but no, we can't do that, because if we did, that would totally dilute everything, all the other benefits you get from Marimo, like reproducibility, rapid exploration, interactive elements, apps, scripts. None of it would work. And so I think like taking a stance on like figuring out what our design pillar was and like just like really being principled of like, no, we can't compromise that. I think that was an important lesson we had to learn early. And like, had we just like acquiesced to that feedback, I don't think our project would be where it is today. I think, yeah, it would have just kind of fell over of trying to do too much. So that was one. But on the flip side, there have been people coming from Jupyter who are like, hey, like your key map, that doesn't vibe. That's not what I'm used to in Jupyter. And like, actually just today we are releasing, I guess by the podcast is out, it'll already be released. But today on the day of recording, we are releasing a new key map that is a lot more Jupyter friendly and compatible. So like meeting people where they are, and when it doesn't dilute from our main thing, like our main value proposition has been important. Like, so that's why we, like, you can convert IPyMB to Marimo Python files and back. We added something that lets you automatically snapshot your Marimo notebooks as IPyMB in the background if you do want your output saved. So that was a lesson that we learned of. It's important to build bridges for like like compatibility with existing users and how they work, so long as it doesn't dilute our main sort of pillars or design pillars.
And so for people who are looking for a notebook utility, they want to be able to have some sort of interactive data exploration. What are the cases where Marimo is the wrong choice?
Yeah, let's see. I think if you don't code at all, so like I think like, or you, like if you come from a background where you are more comfortable using like point and click tools for like building UIs and building dashboards, and you don't want to write Python and you don't want to write SQL, Marimo is not a good choice. Like, we're pretty code forward. We do have LLM assistance built in and increasingly building that out. So like the LLM will generate your code for you, but like as we all know, you kind of need to be able to proficient to be able to read that code and edit it to kind of fix it up. So that's one use case. Another use case where I think Marimo is not a good fit is developing traditional software. So like there have been movements in like in the past, like in literate programming and like other tools that like try to use notebooks to like just build regular software that honestly don't even have to do with data. Like, I would definitely not recommend that. Like, we don't use Marimo notebooks to write Marimo itself, right? We just write Python directly. So I think Marimo really shines if you like writing Python, you like writing SQL, and you are explicitly working with data, not I don't know, building some software system that only is tangentially related to data, if that makes sense.
And as you continue to build and iterate on Marimo, you've mentioned a little bit of some of the forward-looking roadmap, some of the areas of potential focus for your commercial offering. I'm curious if there are any particular features or projects or problem areas you're excited to explore.
Yes, definitely. So one is a very native VS Code extension actively being developed. We talked about pipelines sort of being sort of ideated on more sort of agentic. I mean, it's a buzzword at this point, but there is some value, or like more agentic sort of AI support in the Marimo editor itself. I mean, people do actually use Claude Code with Marimo notebooks today, and it works pretty well. But like, there's even more value you can get if your LLM, like ours does, has access to the data in memory. Beyond that, one thing that we are launching this week, and by the time the podcast that comes out, I assume will already be launched, is an alternative to Google Colab, mostly for a community. So like a hosted Marimo notebook service that we are, as long as your usage is reasonable, we are giving away for free, because we realize people want to build community tutorials and things like with Marimo notebooks and just like add a link to their GitHub README. It's a little tongue in cheek, but we're calling it MoLab, Mo for Marimo. And the reason, like the sixth or seventh top voted issue on the Google Colab GitHub issue tracker is like support Marimo in Colab. And like, okay, Google's not going to do that, but okay, well, let's just build our own version. And so that's molab.marimo.io. So that's something that we've been excited to work on and share.
Are there any other aspects of the work that you're doing on Marimo, the overall space of notebook style computation, or the work that you're doing on the Marimo commercial offering that we didn't discuss yet that you'd like to cover before we close out the show?
I think we covered all of the main talking points and then some. I can point folks to links and places they can find our community, but I think we hit all the talking points.
Well, for anybody who does want to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management and or AI engineering today.
Yeah, I think that's a great question. I think there's like really interesting things happening in the analytic space, and then also by extension the machine learning space. And this is like broadly talked about, right? But like, 10 years ago or longer, Spark and I guess closer Snowflake. It was kind of needed maybe to process data at scale, but like these days with like data fusion, with DuckDB, you can do like a whole heck of a lot of data processing on a machine with a terabyte of RAM. And I think people have theses about that, like MotherDuck has a thesis, Polars and Polars Cloud has a thesis about how that's going to change the way that we work with data and like the kinds of data platforms we build and use. I think and yet still somehow everyone is using Databricks and Databricks Spark, even if it's like a 20 gigabyte data set. So I think there's like some kind of weird impedance mismatch of like the tools that the industry is using and broadly in an enterprise setting, and also the tools that are now available. Like I talked to so many like startup founders and like big companies, and they're building cool things, very performant engines on top of data fusion. Like this technology is out there, and I think because of it, like we're going to see a tool landscape change. I don't exactly know how, and I don't know what it will look like, but I think there is an impedance mismatch, and I think our tooling is going to reorient around this new reality.
Yeah, it's definitely been interesting seeing the effect that Rust in particular, but also Golang has had on the overall data computation space, where Java was the behemoth of the space for many years now, but I've been seeing a lot of projects that are aiming to re-implement or rewrite or reimagine the core primitives of these very Java-heavy frameworks. Spark, Flink, Hadoop has been suffering a long, slow decline. So it's definitely interesting to see how the overall tooling landscape is getting reimagined as we all mature in this more cloud native era.
Definitely. I was vigorously nodding my head.
All right. Well, thank you very much for taking the time today to join me and share the work that you and your team are doing on Marimo. It's definitely a very interesting project. I'm excited to see that in the ecosystem and experiment with how I can incorporate that into my own data stack. So I appreciate all of the time and energy that you and your team are putting into that, and I hope you enjoy the rest of your day.
Thanks, Tobias. It was a pleasure. Thank you.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.